right, so there is a second method that we can utilize when doing a hypothesis test, and this is called the critical value method. And so again, it's going to start the same way. You're going to state the null and alternative hypotheses, and there's going to be an alpha level for this. Now, where there's a little bit difference, and I do this a little out of order, is we're going to find these critical values on a chart, okay? And so kind of the idea behind here is, going back to that idea of the trial, is I have a predetermined line in the sand that I have to get to, okay? And so if that is that I have to have a motive and a victim and a weapon or whatever, and then I have to have a physical tie-in, if the prosecutor does not present me with all of those objects to get me, or all of those things to get me past this line that I have indicated in the sand, then I will not convict them, okay? I will fail to reject our null hypothesis. Now, if they get me past it, it doesn't matter if I'm a far ways past it or a little ways past it, I am going to reject, okay? And so we're going to talk about how to set this up. Now, finding our test statistic is done the exact same way. So we're going to talk about how to do this. Now, first off, I'm going to discuss just how to find, okay, this critical value, okay? So if you are doing, okay, a left-tailed test, then this critical value will be, say, here. And what we're indicating is that the alpha amount, so whatever that is this amount that's down here to the left. Now, when we do our test statistic, if our test statistic is here, okay, so if this is our test statistic that we find, we have not gotten into this dark region. This dark region is our reject region. This is basically where I would convict them and find them. So if this is where this is, then I would fail to reject. Okay. Now, if, however, my test statistic was here or anywhere in this dark, then I would reject because I'm down here in this other end. Now, by similar fashion, a right-tailed test is going to put alpha over here. And in a two-tailed test, half of my alpha is down here, and the other half is up here. So if alpha was, say, so let's say alpha was 0.10, then this would be 0.05 down here in this end and another 0.05. Now, if you recall from when we did confidence intervals, these will mirror match each other. Okay, they will mirror match when we have those when we have that two-tailed type testing. So, for example, okay, if I was going to do, say, a two-tailed test, I'm going to have a two-tailed test, and I'm going to set alpha to be 0.01. Okay, now what that implies is I need half of that, so 0.005 down here. And again, we're going to know that this mirror matches. So if I work with my table, okay, and I try to find as close to 0.005 as I can possibly get, okay, and I'll move this down here real quick. Okay, we get between this 049 and 051, okay, and those are smack split between, which is at negative 5.7 and negative 5.8. So we're going to split the difference right between them, which means my critical value, and in this case there are going to be two, this is going to be at negative 2.575, and this will be at positive 2.575. Okay, there's where those would sit. Now again, if my test statistic lands in this white kind of unshaded region in the middle, then we will fail to reject. If it ends up in either, okay, and that's kind of one of the things that happens with the two-tailed test, if it lands in either one of these, then we would fail, then we would reject. So if we land in the shaded region, we would reject. So let's take a look at a couple of examples for this. And again, we're going to see some of the same types of processes that we had, okay, in the p-value approach, just slightly different setup. So a researcher reported that 71.8% of all emails sent in a recent month was spam. A system manager at a large corporation believes that the percentage at his company may be 70%. He examines a random sample of 500 emails. We have 500 emails received at an email server and finds that 373 were spam. Okay. Now, can we conclude that greater than 70% are spam? And they want us to utilize alpha is 0.10, and then separately we'll do one at the 0.01 level. Okay, so we'll do both of these separately. I'll draw two different things. Okay, so first off, null and alternative. They said greater than 70. So that's an strictly greater than, so that's an alternative statement. So we'll put this one at 70. Okay, now here's where we do things just a smidge bit different. Okay, I am going to go ahead, because this is greater, this is going to be a right tail. And so I'm going to go ahead and draw my setup up here. So I'm going to put a right tail over here. And we're going to start with this 0.10. So alpha is going to be 0.10. Now, since I'm doing to the right is 0.10, to the left we need 0.90. And again, I'm going to go look at my chart, and I'm going to get as close to 0.9000 as possible. Okay, and it's going to sit at 1.28. Okay, so now this is my critical value. This is what I'm going to be comparing against. So I'm going to show this next little bit in color so that you can see what I'm doing. So now, finding my test statistic. First off, p hat is 373 out of 500, which is 0.746. Now, to find my test statistic, it's going to be 0.746 minus 0.70 over square root 0.70, 1 minus 0.70 over 500. Okay, and this is 2.24. Okay, this is my test statistic. Now, I've got to put this value on this number line, and I kind of already know where this is. So where is 2.24? 2.24 is going to be right here. So at that level, we would reject H naught, which means we do believe that greater than 70%. Now, let's talk about this other one for the 0.01. I'll draw my picture. So I'm going to color. This up here is 0.01. Okay. Okay. Now, again, looking at my chart, trying to get, if 0.01 is on this side, I've got 0.99 on this side. Okay. Looking that up in my chart, I get that this is at 2.33. Okay. So 2.33 is critical. Where does 2.24 live? 2.24 is going to be right here. We're not, let me darken that up for you. We are not in the reject region. So at this level, okay, at this 0.01 level, we would fail to reject. Okay, so again, now this would normally be two different problems. It would be just the 0.101, and we would find that answer and be done with it, or it would be at the 0.01. They don't usually have us doing double comparisons with this as we go, okay? So let's take a look at another one. Okay, so a news poll conducted in 2012 asked a random sample of 1,268 adults in the United States how much confidence they had in banks and other financial institutions. A total of 144 said they had a great deal of confidence. An economist claims less than 11% have a great deal of confidence in banks. Can we conclude that the economist's claim is true? They want us to run, again, they're going to have us run 2 of these. So we're going to do alpha is 0.05, and then we're going to have alpha is 0.10. Okay, so we're going to do both things. So again, we're going to start here, less than. So H naught, H1 is going to be less than 0.11. So this will be equal to 0.11. Okay. So now I'm going to start with this one. I'm going to draw my shape. This is a left-tailed, okay, because of the left then. So I'm going to put a mark here. This in here has to be 0.05. And if we look that up on a table, we're looking for 0500, as close to that as we can possibly get. This is, we're going to split difference here, okay? Negative 1.645, okay, is where that's going to land. So here we go. We're going to find our test statistic. So 144 out of 1268 is 0.1135646. Okay, so I've got 0.1135646 minus 0.11 over square root 0.11, 1 minus 0.11 over our 1268. Seven, 8, 6, 3. Sorry, there's all of that all together. And this comes out to be 0.41. Okay, so again, going up here and looking at where that's going to be, y'all, 0.41 is actually going to be to the right of center because it is positive. So at that, we would fail to reject. Okay, I'm going to fail to reject that. Now, again, we're going to look at doing one of the, they also want us to check on the 0.10 option. So we're going to look at that one. Okay. So we'll draw that picture. So now I'm going to put my alpha down here. This has got to be 0.10 down here in this bottom end. So again, looking that up in my table, I get negative 1.28. Okay. And again, 0.41 is still kind of sitting over here in the same position. So even at my alpha equals 0.10, okay, we're still going to fail to reject. Okay. Now we'll look at one more. Okay, so again, we kind of done a left-tailed and a right-tailed. So let's take a look at what a two-tailed will look like in this kind of critical value approach. So here we go. In 2013, a consulting company asked 1,039 adults whether they believed that people should pay sales tax on items purchased over the internet. Okay, 436 supported this tax. Okay, does the survey provide convincing enough evidence that the percentage of U.S. adults who favor internet tax differs from 38%? Okay, so here's that key phrasing again. So here we go. H naught, oh, sorry, and alpha is 0.10. So we're only having to do kind of a straightforward one with this. So differs is, it is something other than what they state, so 0.38. So then the null is going to be that it is equal. Okay, now again, we're going to go ahead and set this up. Now, picture-wise, what's going on here? This is a two-tailed. Okay, so I'm going to have kind of two zones over here. Now, what's going to have to happen? Half of this 0.10, so 0.05 is going to be down here, and 0.05 is going to be up here. Now, we do know that this is going to be a mirror match. Okay, so I can find this one down here, and then it will match on the other. Now, based on the one that we just did, we did do one where we found a 0.05 all in the left end, and that was at negative 1.645. So that is going to be there, and then we're going to have 1.645 over here on this one, okay? So now we're going to do our math. So we have P hat, that's going to be 436 out of 1,039, and that is going to be 0.4196342. Okay. Got a glare here. So I've got 0.38, sorry, no I don't. I have P hat, so 0.4196342 minus 0.38 divided by big square root 0.38, 1 minus 0.38 over our 1,039. So our test statistic is this 2.63, okay? So now going back up here to our pretty picture, where does 2.63 hit? 2.63 is out here. So we're in that dark zone, so we reject H naught. Okay, so we would reject H naught. Now, what that says is we do have enough evidence to say that it is different than 0.38. I don't have to say whether it's higher or lower. Now, we can tell what we think it might be, but that wasn't our job. We just have to say that it is something other than, or that there is enough evidence to support that it is something other than 0.38. And in this case, we can.